I know that some of you are not really familiar with the Graham's law of fusions, but we'll be discussing this one. But first, we'll need to unlock the words. When we say about when we talk about Graham's law of fusions, it includes the words diffusion and effusion. There are two differences, or I mean, there are differences of these two words. When you say diffusions, okay, we'll talk about first diffusion. When you say diffusion, it is the ability of two or more gases to mix spontaneously until they form a uniform mixtures. Like for example, you have a certain gas in this container and you mix it in the other container here. So when they mix together uniformly, they are called diffusion. That is the word diffusion. Or like for example, you are farting. So you are exerting another gas, which is methane gas from your anus or from your body. So that smell is can be smelled by the persons beside you, but by time passes, like a minute, that smell will be vanished. In other words, they diffuses. They combined that certain methane gas combined to the air or to its surroundings. That is what we call diffusions. So when we talk about effusions, that is another words which is talking about the Graham's law of effusions. When we talk about effusions, I'm gonna write here effusions. Effusions. It is a process by which a gas molecules pass through a very small opening from a container of a higher pressure to an area of lower pressure. So, like for example, this is I've exampled earlier diffusions when they uniformly combine. So when we talk about effusions, when this one here has a low pressure and it moves down here, which is what we call diffusions. When a certain gases move to a small hole, that is what we call effusions. That is why there is what we call rate of effusions. Since when we say rate of effusions, it is the speed of a certain how a gas is effuses, which is called rate of effusions. Okay. So when talking about the Graham's law of effusions, sorry for that. So when talking about the Graham's law of effusions, um, it involves also another definition. So when talking about this, the Graham's law of effusions states that a rate of effusions of two gases are inversely proportional to the square root of their density or molar mass, expressing the rates of effusions of two gases, one and the rate at the same temperature. So in this case, when talking about the Graham's law of effusions, there is no there is a same temperature of the two gases. That means the temperature of two gases are constant. Okay. So what are they what is the main goal of Graham's law of effusions? It states that when a certain density, when you have higher density, this is a symbol of density. When you have higher density, it's look like a P, but it's like this one. This is what we call the symbol of density. So when you have higher density, according to the Graham's law of effusions, you'll be having lower rate of effusion. So like I put here, rate of effusions. That's why. So you have a higher density, you'll be having low rate of effusions. Why? Because talking about density, density is containing talking it involves volume, right? Density involves volume. So when it involves volume, um, it involves gram and its volume. So when there is higher density, when we say density, it's a like for example, this certain Coke is dense. So it's in other words, it is hard. So that means if you have hardened this much more, this one does not move higher, right? So that means this one will move. This one will move slowly. That is why, according to its Graham's law of fusions, when it will be talking about gas this time, when there's a higher density, this one the rate of fusions get lower. That is why if you move this one, it's a lower rate of fusion. Like for example, if you drag a certain higher density or a very dense table, it is low of its rate of diffusion, low speed, low rate. The same thing in the gases. So when there is a higher density in a certain gas, the rate of effusions as it effuses in the whole is lower. That is the Graham's law of effusion stated. So we can call that we can form a formula like this. So rate of effusions, in other words, rate of effusions, I'm gonna write it here. Rate of effusions of gas 1 over rate of effusion of gas 2 is equals to square root of its density 2 over density 1. Why this is a formula? Because as I have told you earlier, they are inversely proportional. That is why look at here. Rate of effusion gas 2 is in the lower, but the density is in the higher, right? It's in the top. That's why they are inversely proportional. Gas 1 is in the lower, and then the gas 1 is in the top, and the density is in the lower. So that means they are inversely proportional. Okay. So like for example, you have a certain given problem. When you are asked how fast, I'm gonna erase this. Okay, I hope you copied this one or you can rewatch the video so that sorry for that. My phone is very um sorry. Okay. So maybe I gonna get it slower now. Okay. So like for example, you're asked how fast. We'll use the formula. How fast is the rate of effusion of H2, which is hydrogen 2, compared to that of oxygen 2. Okay. Okay. So with a given gram, yes, earlier I've told you density, right? So it's the same thing with molar mass. Since molar mass is expressed in gas, so you can use density or you can use molar mass. I've stated it could be a rate of fusions depending on its density or in its molar mass. So this I'll be talking about the mass. Okay, so let's write the hydrogen 2 is 2 grams and the oxygen 2 is 32 grams. This time we'll be need to solve. The question is how fast the rate of effusions. So they are being compared. Their both rate is being compared this time by the given molar mass. So we can write a rate of effusions. The formula. Maybe I just write it here. RE1, which is rate of effusion 1. Okay, divided by the rate of effusion 2. This is the formula, right? And then square root of what is the next one? Mass, molar mass. So you can write here mm, mm2, and then m1 since they are inversely proportional. Since you are just going to compare their their rate of effusion, so you can directly write the square root of what is a given molar mass mm2. What is the mm2 here? Which is the 32 gram. Since it's the second one, 32 grams. 2 grams over 2 grams. So this time you need to divide them. So 32 divided 2, you'll be having 16. Then square root of 16, you'll be having 4. That means their rate of fusions, or their distance of its rate, is 4. This time there is no unit because this 1, the gram here, will be cancelled out. So it is just indicated that the rate, how far they are from each other based on the rate of fusion, is 4. Okay. So this time we'll try to solve something like different. So using this formula. Okay. Maybe I'll erase this. And I will not erase the I erase the questions. Alright, except the formula. Okay. Like for example, you have the given rate of diffusion. When we say rate, it is speed, right? I've told you earlier. So, like for example, you have the given rate of fusion for number 1 and rate of fusions for number 2. How will you be able to solve this? Okay, let's try to solve this. Okay, like for example, you have a given, this one, given. I write here given. Okay, so like for example, your rate of fusion 1 is equal to 26.5. So since it's a rate, it is expressed in ml per minute. So there's a minute, that means as a speed. There's a time. Okay. And rate of diffusion 2 is 20.5 ml per minute. So you are asked to get, like for example, you are asked to get the density 1. Okay, right here density 1 is being asked, while your density 2 is equal to 4.1 gram per ml, since it is a density. So using this formula, okay, you need to derive the formula, right? So you are asked, this is maybe I'll just change this into a density. This is the original formula. You need to derive from the formula if you're going to answer this. Okay, like but here density 2, since they are inversely proportional, density 1. So you are asked to get the density 1, but then by this formula you cannot, take note, you cannot derive this because the density 1 is in the denominator, so you cannot put p1 there or p2, since to cancel out them both sides you cannot put p2, right? Or I mean density 2, because this one you cannot cancel out. So what you're going to do is to you're going to swap them. So since they are inversely proportional, swap them both sides. So put here, change the formula, put here rate of fusion 2 and rate of fusion 1. How about here? You put rate of fusion 1, density 1, and here r is 2. So you can now solve solve this one. So density 1 is in the upper one. So you can put here density 2 both sides, put here density 2, cancel them out. So, and this here, since you need to okay, so now you have the formula of since we are asked to get the density one, you need to go back. So you'll be having, I mean, you need, since it's a square root, so, and then it is square root, so you need to go back into its square, right? So you need to square this one. So you can put this like formula, density 1 is equals to square them, the rate of effusions, 2 over rate of effusions 1. And then put some, and then multiply by the density 2. That's the original formula now. So you put here density 1. So, and now you need to substitute its a value. Rate of fusion 1 is 26. I sorry, 2 there. Okay, rate of fusion 2 is 20.5 ml per minute over 26.5 ml per minute. Multiply by the density. I don't have any space, so um, just this one is 4.1. 4.1, huh? Okay, 4.1 for density. Okay, I don't have any space now. Maybe I'll rewrite this. Sorry, I rewrite this. So it can be the density 1 is equals to, I mean, rate of fusion 2 is equals to 20.5 ml per minute over 26.5 ml per minute multiplied by the density of, what is the density? Yeah, you need to square this, squared 10 times or multiplied by the density 2, which is 4.1 gram per ml. So the unit here, ml per minute, will be cancelled out because it's division. So 20.5 divide 26.5, we'll be having 0.77. Then square them, use your calculator, click squared, this one, click this one, squared, and then you'll be having 0.59. 0.59 and so on. So, or you need, or you can directly multiply 4.1. Then multiply this one to 4.1. Then you'll be having the final answer of, so density 1 is equals to 2 point, density 1 is equals to 2.45. 2.45 gram per ml. So now you have the density. That's the easiest one. Okay, I hope you understand the lesson. Goodbye and thank you. You can message me in my Gmail account for any clarification.